we're always going back and redoing technology and trying to integrate in new stuff. So we wanted to come up with a way of making that easier and having it so that when you want to build something new, you don't have to basically start over from the beginning. So we have kind of a component platform where you can just drop in a bunch of components, you have a timeline, and you have a bunch of really powerful tools that you can use to get things up and running. And we can integrate in things like AI and different types of radios and different radio protocols. So we wanted to make a product that's very visible and easy to understand.
The most difficult thing is how quickly can you get this product into the market? In traditional methodology, you're sometimes waiting 4 to 6 months for even a prototype, and the engineering overhead that's needed to accomplish that. And as Ken had cited earlier, nobody wants to get in another developer's code. And so it just becomes very, very tricky to move forward, iterate, field test, and get those questions answered before you start actually putting the product in the market. The use case we're highlighting here is from our good friends at Farber Lockers in their quest to create smart parcel boxes for UPS. They had worked with another traditional methodology company, and it took over $1 million and a year to get a black box. So there was closed source firmware, there was no visibility, usability, or scalability. And ultimately what they wanted to do was create a smart locker. So again, these locker boxes are placed all throughout locations in the United States, and the drivers are making these stops, spending millions of dollars a month, and the drop boxes are sometimes empty, or maybe the boxes are vandalized. And this costs time, this costs money, and the drivers weren't able to get any feedback or insight as to whether or not something was in that box. We're actually going to be building the product that's behind me. Let me lower my camera a little. So these are Farber's parcel boxes here. When they were introduced to us, they were not so smart, no sensors or anything inside of that. So today I'm going to use our Bekonix platform to create a digital twin of an existing product that's already out in the market. So what we're going to do is we're going to build the hardware first. So we start with a blank slate. I'm going to add some hardware onto my screen here. So add components, and I've already preloaded this here for the sake of our demo, but you can have some time to peruse around there. Initially, we always start with an image. It's easier to understand and easier for maybe non-technical people to comprehend what's going on when you have a picture in place there. So I'm dropping my locker here. So exactly what's behind me, you can see that side of it there. Next, I'm going to add the brains of the operation here. So this is going to be our microcontroller here. And so we have our own hardware that we developed here. So this is a Bekonix Connect development board here. It's equipped with inches to anywhere connectivity, which includes Cat-M1 and LTE. That's supplied by Monogoto. So we have T-Mobile, Verizon, and AT&T access, in addition to 500 other carriers worldwide. GPIOs, LoRa, NFC, GPS, NB-IoT. So any way you need to get connected, we have that capability here on that board. The next thing I'm going to do is I'm going to drop out these sensors. So as it is, the box is not smart here. So adding some Hall effect sensors, I know whether doors are opening and closing using the change in magnetic field. And I'm adding another Hall effect sensor here on the main door. So this is the one that UPS or the delivery driver would access here. Next, some motion detecting sensors, passive infrared. And these ones here, what they do is they detect that something's actually dropping in the box. So we know it's not just somebody coming by, flipping the box open and close, but rather something is actually being inserted in the box. Then we talked about messaging. So in this case, for this particular project, we're using HiveMQ as a protocol, and then a timer. So part of sending those messages is the ability to send them at a scheduled time or in an instant when that trigger is taking place. So this is all of the hardware used to create this box. Then you'll notice that as I was dragging and dropping each of these components onto the workspace here, that there's both green and blue lines being traced from the component to the development board. The blue lines signify that it is an input device. So it is taking in some sort of external action there. The green lines are our output. So this could be alarms or lights, or in this case, MQTT messaging. And that's it right there. So let's go into building the firmware. We go to device setup from there. And our platform already has, based on the board that you're using, the type and configuration needed to plug all of these components in. So you'll notice that there's red, green, and black. So green corresponds to your digital signal. Your red is your power, and your black is your ground. You'll apply the settings, and all the firmware that's needed to make all of these guys run, or the drivers rather, they're automatically uploaded onto the development board, and you're ready for going for software. So I have a kind of a cake in the oven already built for us. So let's jump over to that, and we'll go to our software screen here. So similarly, you can see all of our components here, all that we've previously laid out, with the addition of a camera here. Ken will tell you a little bit about that in a second. But each of these components have their own dedicated timeline here. This timeline can run synchronously and asynchronously. You'll notice these little tick marks here. Those are what we call triggers. So those are telling the sensor that at this specific time, we're going to have a specific action. So each component has its own track here. And if you click on the timeline here, you can see that it highlights which track it's going to be working for. And so here are our inputs, and here are our output messagings. And I think this is best showcased by simply getting this project moving. So what I'm going to do is I'm going to upload this project to my device. So I'm going to upload this to our device. We were already connected to it. And you'll see over Bluetooth, it's uploading the project right to our box here. So one of the important tools that we have in our platform that traditional methodology lacks is in-the-moment debugging. So each component has its own built-in waveform monitor. So as Ken is opening and closing in the box, you can see that the Hall effect sensor is dipping. And you'll see that those triggers are also represented here on the platform. We'll open and close the door. There's our second Hall effect sensor going. And then the motion sensors. You'll see as he dips his foot into the space there, those are triggered as well. And as he's doing that, you can see on the timeline down here how those move as well. So go ahead and do some more triggering there, Ken. You can see automatically that all of these track marks are moving, and based on the sensor that's being triggered, it corresponds to these timeline tracks here. So now what we're going to do is we're going to show you the radio. So the connectivity that Monogoto allows us to have here. And I'll kick it over to Ken to describe this panel for us.
Yeah, so at the top, you can see right now we're connected to T-Mobile, and the graph at the bottom, that shows the power savings mode. So the blue bars indicate that in those hours, this is like the last 24 hours. So this allows you to quickly make sure that it's actually going into a deep sleep mode, so it's conserving power. And then if you want to make changes to the radio, on the ... button, if you wanted to go to like AT&T or Verizon, you would just select the carrier, and then it would register with that carrier. So it's very easy to configure. Once you've configured the radio, it's ready to go. And then if we can bring up maybe the other panel, we can actually see the messages going out. So this is a kind of a debugging panel for us. But right now you can see it's querying the radio, asking what the current signal strength is. Now as Nicole is actually opening and closing doors, you can see it's actually sending out messages. So those are messages triggered by the tracks below. And then on the timeline, the actual events, you can see the ones that have the cloud upload. You can see we've got a little editor here that allows you to edit the JSON.
Cool. And so once we've completed this project and you're satisfied with everything, you simply just take the project and you just drag it over to the device. And there it'll live on the device. This is manufacturable ready code. But wait, there's more. Not only do we now can we now give the driver signals for packages being inserted or not, they wanted additional visibility to saying, hey, what's actually in the box. We had previous cases where chicken wings were dropped in the box, so that was kind of funny. And then another issue that this company was experiencing was vandalism. So you'll see this little camera here, and I'll kick it over to Ken to talk about how important iteration and flexibility is in product making methodology here.
Yeah. So our reliability with the sensors that we initially put in the box was very high, but we wanted it to be even higher. So what we did is we built a little AI module that actually has a camera on it. And so if you can see that. Yeah. So you can see this is what it actually looks like inside. It actually goes inside a box. Okay, these are a bunch of different AI models. So this is a model we'll check to see whether or not there's any packages in the box. So what I'm going to do is I'm going to connect to the device. And then I'm going to hit upload. And now it is running, and I'm going to bring up the camera control panel, and I'm just going to hit snap. So I'm going to manually tell it to take a picture and then run the AI. And this just takes a few seconds. So you can see, here's the result. This is the package box is not empty. And then you'll see in a second here, you'll actually see the picture of the inside of the box. So we can either upload just the result of the AI detection, or if we want to upload the image, we can do that, depending on whether or not we want to conserve bandwidth. But then in terms of running other tests, so if we want to, find out whether or not the box has been vandalized, or maybe we're suspicious that something has gone wrong, we can, check to see whether or not the door is properly closed. And I just dragged and dropped a different AI model onto the timeline, hit upload. And then I'm going to go through and just hit snap again, and it's going to run a different AI model. So I'm manually doing this right now, but you can actually just put in the timeline. You can schedule them on timers or whatever. So it's a very flexible way of running different AIs. But you can see it says 99% sure that the box is open, and it is in fact open.
One of the biggest takeaways and lessons learned, I guess, is the ability to continuously iterate. When this, an example, this company coming back with a $1 million black box, it's just unacceptable. You have to be able to iterate, and having a platform where you can have digital twin technology and debug in the moment and work collaboratively with engineers or teammates to build the product, you're geared for success. So like I said, if you have just a box that has all these great sensors, Monogoto's connectivity allows you to keep your clients abreast instantaneously.